Hello. Everything should be working. Should be able to hear me and should see the desktop. Does that seem okay?
Yes, Professor.
Oh, okay, great. Thanks. All right. Okay, everyone's here. Now, what we're going to do today is talk about language 3 and homework 2. Now, homework 2 is almost ready. I was working on it today. It's still not there, though I have it on my desktop. So it's not, I didn't get a chance quite yet to copy it up to the web server. And I can show you the idea of it, but using the copy that's here on my desktop. Okay, so we'll go over a little bit about homework assignment 2 and its relationship to language 3. Okay, okay. So let me download language 3, and actually I should probably download language 2 also because they're compare them if we need to compare them. Okay, all right. Okay, so okay. Get these extracted. Okay, real quick, just a reminder of what the languages are. Language 1 is arithmetic expressions. So you can run language 1 and you can type arithmetic expressions in prefix form. Okay, no variables, but addition, subtraction, multiplication, and division without any variables. There is no variables. This is just a desk calculator, but you can, okay. So the grammar of that language, and then remember the way we're going to do it is language 1 will be part of language 2. So everything that's valid in language 1 will be valid in language 2. Everything valid in language 2 will be valid in language 3. So language 1 is just the language of arithmetic expressions. And you group them. It's a prefix it's a prefix language. So things are grouped by saying that's the multiplication of the sum of 5 and 6 with the subtraction of 6 and 7. Okay, so you have to read it. It's the multiplication of the sum of 5 and 6 with the subtraction of 6 and 7. All right. We don't have that. We don't have operator precedence because when you use a prefix notation, there's never any ambiguity. You never have things like 4 times 5 plus 6, and you have to figure out which one gets done first, the plus or the multiplication. With infix notation, you have precedence issues. But with prefix notation, that's one of the beauties of it. There's no precedence issue because the parentheses, everything's grouped in parentheses. So the only rule is do whatever's inside parentheses first. Okay, so that's language 1. Okay, language 2 adds Boolean expressions. So language 2 takes the arithmetic expressions and adds Boolean expressions, and it adds the Boolean data type. So now you can have values that are true and false, and you can do and or not with the true and false, and you can also do relational operators on numbers. Okay, so language 2 it has integer literals. Oh, but notice that since the language, you can type any kind of a value, the values are stored in these special value objects. And the reason we do that is, well, it's mostly for what we're going to do in the next language when we have variables. But a value object can hold either an integer value or a Boolean value. And then there's a tag to tell you which one is the valid one. So this one's holding false in the Boolean part and 345 in the integer part, but it's really an integer value. Here's a Boolean literal. So it's a value object with the tag bool. The integer value is 0, but we ignore it because the tag is bool, and the Boolean value is false. Okay, And then I can do, if I multiply two numbers, I get an integer value. If I take the ANDing of two Booleans, I get a Boolean value, okay? And I can do a less than operator on two integers, and I get back a Boolean, because the less than is a Boolean operation on integer values.
Quick question.
Uh-huh.
For a bool, should value I be 0 or no? Or does it matter?
Well,
Oh, because 0 is false. That's true. But
no. That's not the way you're supposed to look at it. When a tag is bool, the value I is ignored.
okay.
Yeah, you look at the tag and you either look at this field or this field. It is not that 0 is analogous to false. For example, look at this value, true. See, it's a Boolean.
All right, it's still 0.
Ignore that value there and look at this one.
Okay, thank you.
Yeah. So these are what we call tagged unions. Okay. It's got a Wikipedia page. What's a tagged union? Okay. It's the way interpreters it's the way JavaScript and Python typed interpreters handle values. They handle values as these things called tagged unions. What that means is a value is a combination of an integer and a Boolean. So that's the union. But you don't look at both value parts. You only look at one part. So the tag tells you which part to look at. So our value object is a union of integer and Boolean, but the tag tells us which one of those two we should look at. Okay. So if the tag is Boolean, you just couldn't care less what's in that value I. And if the tag is int, you couldn't care less what's in that Boolean tag. And I could have set it up so that the opposite value was null, but I didn't do it that way because null is not in Java, null is not an integer value. So the value I is an integer value, and Java doesn't let me put null where there should be an integer. So same way, Boolean is a primitive type. So Java doesn't let me put null where there should be a Boolean. So if that was the case, then I wouldn't need the tag, because then I could just say, look at which one of these is not null. But Java doesn't let you do that. Java doesn't let you put a null in place of a primitive. So I went ahead, these are primitives. And then if you look at the value class, okay, so it has an int and a bool. I could have made this an integer wrapper class and a Boolean wrapper class, and then I really wouldn't need the tag. Then you would have one of these was null and one of them was not null. And that would have been a design choice. I could have made this like that. And then always had one of them null and one of them not null. Then the one that's not null was the one that was tagged. Okay, so instead of having three fields, a string and an int and a bool, I could have had an integer field and a Boolean field. I just didn't feel like doing it that way because that's not quite the way it's usually done. I thought it was, this is the kind of the way it's more often done. Okay, but then I wouldn't need the tag at all. See, if I did it this way, I wouldn't need the tag, because then I could just say one of them is always null and one of them is non-null. So your actual value is the one that's not null. Okay, but I decided not to do it that way. Okay, so I'm using three fields, the tag and the the two primitives, a tag and two primitives. Okay, and I made the tag a string. I could have made the tag a Boolean because there's only two values, but later on these values will end up with multiple values. so I made the tag a string. I could have also made the tag a enum, which is actually the more correct way to do it. The tag itself should be an enum, an enumeration. So it should be an enumeration of the different tags. But I kept it kind of simple. I made the tag a string because Java enums in Java are kind of clunky. So I made the tag a string, so it's either int or it has to be either the string int or the string bool. But a better way to do it would have been that the tag is an enumeration, an enum. Okay. All right. So the big thing about language 2 is that it, besides giving you Boolean expressions, it changes the nature of what a value is. It needs a value object to hold the values that could be either ints or Booleans. Okay. Okay. Then language 3 gives us variables. Language 3. Okay. The Boolean part hasn't changed, and the arithmetic part hasn't changed. So all that's the same. What's new are these two pieces of the language. Okay. I put in a print statement so you could print out the value of a variable. Okay. And here's the statement that lets you declare variables. You use the keyword var that declares a variable and gives it a value. Variables have to be initialized when they're declared. This is a language where you can't, like in Java and in Java and C and C++, you can just say int x, and you don't have to initialize the variable. Except in C, that means the variable is really uninitialized. In Java, it just gets a default value. Java doesn't really have uninitialized variables. Well, it does in some situations, it doesn't in other situations. Java, it's actually worth going and thinking about the rules about Java and uninitialized variables. Okay, there's an example of an uninitialized variable. Does anybody know what's the rule here? Hey, quick, interview question. What's the rule? These are kind of questions that are on the certification exams. You can get Java certified, and the exam is just full of questions like this. What's the result here? Does anybody know? Take a guess. Any guess?
Would it be just some type of null value or maybe the address of that
It's a
variable?
primitive. It doesn't have null. Null is a certain kind of pointer value. Int is an integer. It's not a reference variable, so it can't be null because null is only a value that a reference variable can have. Okay. So what else what other possibility is there?
Whatever value was in that location last.
That was what C would give you.
Okay,
Yeah,
sorry.
that's what C. Yeah, that's what C would do. Whatever happened to be in there. Okay. What's another possibility?
0.
0. Yeah. In some cases, that's what Java does. In some cases. What's another possibility? One possibility is a garbage value. That's what C and C++ tend to do. One possibility is a default value. And Java does do that some places, but that's not what it does here. What's a third possibility? Does anybody have a third guess?
An error?
An error. Bingo. Variable X might not have been initialized. In Java, it's an error to use an uninitialized local variable. Okay, now that's a local variable. Okay, now let me go up here and do something else. This is a static variable, y. Oh, it compiled. Notice, uninitialized y, print y, it compiles, but it wouldn't print the x. Okay. X won't compile, but y does. Okay, so comment out the x one. So what do you think the value of y is when I print it?
0.
0. Yeah. In the case of a static variable, see, it initialized it automatically to 0. And you can actually see it up here that it initialized it to 0 automatically. It shows you here. See, when I start the visualizer up, you see that that thing is automatically initialized to 0. Static variables are initialized automatically to 0. What else is initialized automatically to 0?
Arrays.
No.
If you had an array of ints. Then...
No.
Oh, that...
Well, yeah, the entries in an array are initialized to 0. Yes, the entries in an array, an integer array, are initialized to 0. That's another case. Yeah. So static variables are initialized to 0 if they're an int. Integer arrays in the heap are initialized to all zeros. There's a third example, something else that's initialized to 0. So static ints, integer arrays, and what else? What's that?
It won't let you use that inside main though, will it?
Well, what is it?
And a user could access that.
What is it? Before talking about what you can do with it, tell me what it is.
Well, besides being an integer.
Yeah, because this guy's an integer, this guy's an integer, this guy's an integer, but they're 3 different kinds of integers. This guy's what kind of integer?
Primitive.
They're all integers are
They're all primitives, right?
Yeah. This guy's a local variable. This guy's a what?
Class.
A static variable. Okay, what is this guy?
Public.
Global variable.
Say again? Say again? That was real powerful. I couldn't hear you. What's this guy?
That one is a global
Glo-
variable.
There's no such thing as global variables in Java.
Mhm.
Java has no such thing as a global variable.
Okay, so Mm,
Now, oops. That won't compile. It's declared right there, but that won't compile.
Mhm.
Oh, you could use Z in a non-static method.
What does that mean? What is Z? Java is an object-oriented language. That's a hint. Java is an object-oriented language.
It's an attribute of the object. I don't know.
Yeah, it's an object attribute. It's an instance variable. It's an instance variable. Okay, but if I try to visualize this, I get an error. Non-static variable Z cannot be referenced in a static context. What the heck does that mean? How the heck do I get a Z? How do I get there to be a Z in my program?
Oh, class name here.
Do what? So what am I
Um,
doing?
Dot.
No.
Oh, okay. Oh, you need to make an instance of the.
Yes. Yeah. Class name here, O equals new class name here. I have to create a class name here object. Now, how do I print Z?
O dot.
Yeah, the Z lives inside of O. O for object. Okay. Print Y. Okay, now what's going to happen when I click next? I'm at line 11. What happens next?
I will create the instance.
Yeah, create over here in the heap. It's going to create a class name here object. There's a class name here object with the Z in it. And then I can print out, and what's the value of that Z? I didn't initialize it.
I'm going to go with 0.
Well, it's right there.
Yeah.
Yeah. Instance variables are initialized to 0. So what are the rules in Java? If you don't initialize a variable, what are the rules? What's the rule for local variable?
Have to initialize it.
You have to initialize it. Otherwise, you can't use it. What's the rule for static variables?
Java initializes to 0.
Yep. And instance variables,
To 0 as well.
Java initializes them. And also array entries. Java will initialize the entries in an array for you. So it'll initialize arrays, it'll initialize static variables, and initialize instance variables. It refuses to initialize local variables. Okay. The rule in C is nothing needs to be initialized. In C, everything has whatever garbage value is left in that memory location by the last program that used that memory location. So in C, you don't have to initialize anything, and everything automatically has a value. You just don't know what it might be. If you don't initialize it, the value would just be some random garbage value. Though some C compilers take it upon themselves to do what Java just did. The C language is actually a bit ambiguous on these issues. So some C compilers will initialize your variables for you in a similar way that Java does. But that's considered controversial because if a C compiler does it for you and then you recompile your program with a different C compiler, your program may not work all of a sudden. You know, it would work when it got compiled with one C compiler, and it wouldn't work when it got compiled with another C compiler. So most C compilers will only do the initialization if you tell them to. because it's a non-standard issue. It's a non-standard thing. So by default, they won't initialize the variables for you, but they will if you ask them to. Okay, it's actually one of the big problems with C is all this issue about initializing and all that. Okay, so where were we? In our interpreter is a language that doesn't let you, that forces, it acts like Java does. Well, actually, it doesn't act like Java either. Java is kind of really quirky. Java will let you declare a local variable without initializing it. But then before you can print it out, you have to give it a value. Okay. So you can declare a variable without a value. Okay. But then you can't print it. For example, this is legal. This print line is illegal. This one's legal. The variable can be declared up here and initialized way down here. And when it's initialized, then I can use it. So this won't compile because of that. So if I comment it out, now it'll compile. But it's okay to initialize the variable at some later point in time and then use it. So Java is kind of an odd language. You can declare a local variable without initializing it. There's nothing wrong with that. It's just that you can't use that local variable until after it's been initialized. Some programming languages are like the one we're defining. When you declare the variable, you must initialize the variable. There's no notion of an uninitialized declared variable. In many languages think of this as there's a reason why Java does this. Actually, Java has a real clever reason for doing this. Here's why Java does this. That's a great idea. That changes what we're doing completely. What does final mean?
You can assign a value to it once.
No. Notice what you said. You said it perfectly. You can assign a value to it once. Okay. So what this is doing is it's saying I have a variable that I can assign it to once, and from then on it never changes. But I'm not going to assign to it till later. The way we use this a lot of times would be something like public static. You declare the variable final, and then you read it in from a data source. So you would declare it, and then you initialize it later on by reading it in from, say, a data source. So the declaration, now, without the final here, this is stupid. This is kind of stupid. But with the final there, it's actually a very powerful, clever idea in the Java language. You can declare, this is called single assignment variables. Okay. And, Wikipedia's got a page for everything. Static single assignment. Okay. Static single assignment. That's what Java's letting you do. When you declare a variable as a final variable and you don't assign it a value, you're saying that it's a single assignment variable. It can be given a value one time, but not ever changed. Okay, that's different than languages that do this. See, when you do that, you're saying the variable can never be changed from 17. That's a less useful thing to do. That's usually used for constants. That's what C++ thinks of as constant. This is way more powerful. This is that idea of static single assignment. Okay. You can declare the variable and state that it's a final variable. So once it does get a value, that value never changes. Then there can be just exactly one place where you can assign it. Now, if I do this, okay, now in this program, this is an error because I'm trying to use the variable before it's been assigned. Okay, so I get rid of it. But now this is going to be an error because I can't assign to the variable a second time. I can only assign to the variable one time. From then on, it keeps its value. So that's why Java allows the declaration of an uninitialized variable, because of the final int. Because of the case of the final variables, you get this really beautiful idea of a single assignment variable. This by itself is dumb. You shouldn't be doing this. You shouldn't be declaring a regular variable without giving it a value. There's no good reason that I can think of to do this. Okay. But there's a lot of good reasons to do that. Okay. So Java is an interesting language. It lets you declare a variable without a value. Oops. And our language 3 takes a more kind of traditional point of view that when you declare a variable, you must give it a value. This language doesn't have the notion of declaring a variable and then later on giving it a value. So there is no uninitialized variables in this language. So in this language, the two new things, there's a print statement and a var statement. The var statement that lets you declare variables. When you declare a variable, there has to be some place that remembers the value. Okay. So if I go here and I run, like I'll run, here's the language 3 interpreter. The thing about this interpreter is it's meant to be educational. So if I do this, I declare a variable X. It shows me where it's stored. The global environment is, all programming languages have an environment. The environment is where the variables are being stored. In that case, in the case of Java, the environment is, see, the environment's broken up into the static area, the stack frames, and the heap. That's the environment in Java. The environment is in 3 pieces: the static stuff, the local variables, and the objects. Together, they make the environment where everything is stored. Okay. In our language, the environment is just going to be essentially a key value store. So let me declare another variable, var y4. So that's my environment.
Hello.
Somebody say, ask question.
Okay.
What?
Only.
I can't. What did you say? Do you have a question? Okay. Okay. So the environment is a bunch of key values, and the values are these tagged things. They're the tagged unions. So, for example, I'll add another z var z false. So there's a third var. So now my environment's got 3 variables, 2 ints, and a Boolean. Okay, so the environment is a bunch of key values, the variables and their values. And then if I use a variable, see, I can look values up in the environment. So X is looked up in the environment. W doesn't exist in the environment. So I get undefined variable error if I, okay. So the environment is in this folder as a class called the environment, okay. And the environment is an object that stores variable names and values. So I set it up so that it holds a list of names and a list of values. So I think of that as 2 parallel lists. The first entry in this list is a variable name whose value is the first entry in that list. The second entry in this list is a variable name whose value is the second entry in this list. So I set it up in a real simple way. The environment is a list of variable names and a list of values. And the 4th item in this list is a variable name whose value is the 4th item in this list. So these lists are always going to have the same length. Okay, right? And you can add a variable value to the environment. You can ask the environment, is a variable been defined? Okay, so these are the operations we do on an environment. We can add to the environment. We can ask to the environment, has a variable been defined? Just, let us know, not what its value is, just is it in the environment or not? So for example, when I did this over here, when I said W, I found out that it's undefined. There is no W in the environment. So that was, the interpreter found that out by calling the defined method on the environment object. Okay, you could look up a variable in the environment. That's how you get back its value. Okay, so you look up an environment, look up a value in the environment. Okay, it'll return a null value if the variable can't be found. The environment is a collection of, see, this is an array list of value objects. So when you look something up, you get a pointer to a value, and if the value is not, if the variable is not in the list, I just return null to mean that was not found. Okay, so it's a sloppy way of saying not found. You return null to mean I couldn't find the variable you wanted in the environment. Okay, in more modern Java, this thing should return an optional, but maybe later we can talk about how that works. But Java has something called optionals, and what this thing properly should do is it should return an optional of value. That would be the right way to do this. That's the more modern, fancy way. That it would, because there may or may not be a value that goes along with that variable. But I'm keeping it simple. I'm returning a value object, but I'm returning null when the variable couldn't be found. So you can look up a variable in the environment. You can update a variable with a new value. Okay, if I go over here, for example, I can say val x 22. Now, right now, x is 5. If I do this, I updated it. Oopsie, what did I do? Oh, not val, var. I'm sorry. It's later we'll use val and var. If you do any JavaScript programming, you know that there's, and some other languages, there's a val keyword and a var keyword. And eventually we'll learn the difference between the val and the var keyword. We're using the var keyword here. Okay, so I updated the value of x from 5 to 22. Okay, so that used this update method on the environment. When I used the keyword, when I did the var, it seems like, in this language, it looks like I'm redeclaring the variable. So I'm using this as a way of assigning a value to the variable. So the var keyword is actually doing two things in this language. It's being used to declare a variable and to assign a new value to it. So var Jane false. Okay, I declared, now that declared Jane. Now var Jane 101, that's not declaring Jane. Jane's already in the environment. That's changing its value. Notice I changed it from a bool to an int. That's how JavaScript works. That's how Python works. You can assign any value to any variable. Variables themselves don't have type. It's the value that has a type. Notice that Jane doesn't carry a type. Jane is not an int variable or a bool variable. Jane points to a value, and the value has a type. If you dig deep into JavaScript and Python, they point that out over and over again to people. In Python, variables don't have type, values have a type. Okay, it's the value that has a type, not the variable. That's a real subtle idea. It's actually not a great idea. In Java, the variables have a type. In Java, we're used to and C and C++, the variables have a type. The values have a type also, but what's important is that the variables have a type, and when a variable is of type int, you can only put int values in that variable. In languages like JavaScript and Python, variables don't have any type. So if you have a variable X, you can put anything you want in it, string, bool, int, double, okay? And that's the way our language works here. Variables don't have a type, but values have a type. That's the tag, okay? And for example, it doesn't make sense to add 5 to false. Those are the wrong value types for addition. See, those are the wrong types for addition. Okay, so the plus operation needs two integer type values, and if you give the plus operation the wrong type values, it complains. If you give integer variables, it may or may not be okay. It doesn't matter what the type, there is no type to the variable. The key is, do the values the variables hold have the right type or not? Okay. Like right now, see, Jane and X are both type int, but Z is a bool. So it's not that Z has the wrong type, the value of Z has the wrong type. Z has no type in this language. Just like Python, just like JavaScript, the variable doesn't have a type, but the value currently, now if I do the following, var Z9, now notice that that's okay. See, where that was not okay here, it's now okay, because it's got nothing to do with the variable. It's the value the variable points at that its type that matters. In a language like Java, either plus Z Jane works or it doesn't work. Either the variable has type int and this variable has type int, or they don't. Okay, so in the Java language, it's important what type the variable has. In languages like Python, JavaScript, all these what people refer to as scripting languages, it's the type of the value that matters, not the type of the variable doesn't have a type. Okay, all right. So now if we go back to the environment interface is that you could ask if the environment is a variable, you can add variable values to an environment. You can ask the environment is a variable in the environment. You can, if the variable is in the environment, you can look it up and get its value. You can update the value of something that's in the environment. Okay. The update method, if this variable is not in the environment, returns false. Okay. It will not, it doesn't act as something that adds to the environment. The update could have been written so that if this variable was not in the environment, it puts in the environment with this value. Okay. And I wrote it a different way. Some languages, you can only call update on something that's already in the environment. You can't call update on something that's not in the environment. So some languages, if you update something that's not in the environment, then it gets put in the environment. Here I wrote it so that if you update something that's not in the environment, it fails. Okay. All right, and then you can print out an environment. Okay, so the environment is an object with a small interface that lets us add variables, look them up, and mutate them. So see, we can add variables, we can look up a variable, see if it's defined, we can look up its value, and we can mutate a variable. Okay. So the interpreter maintains the environment. The environment in our language is analogous to the stack. Now, the environment in Java is see how the main has stack variables. The environment in Java is made up of things in the heap, things in the stack, and things in the static area. In our language, the environment is essentially the stack. It's just that one piece, local variables. Okay. Over here, it's really maybe more like, it's hard to say if it's more like the static variables, which are kind of like global variables, or more like the local variables. It's one of those two. It's not the heap. So the environment over here, you can quibble over whether it's more like the static variables or more like the local variables. I tend to think of it as more like the local variables, but you can make an argument that it's more like the static variables. That every time you're declaring a variable, it's up here, okay, in the static area. And there are no instance variables over here yet. Okay. All right. So the language lets you declare variables, and then you can do Boolean and arithmetic expressions on them. Okay. So you can do the anding of W with false. Because I thought I had W in there. Oh, I'm sorry, Z. Oh, I changed it. Oh yeah, I changed Z to an int down here. So Z is, I don't have any Booleans in that. So I could say var X false, var Y true. Then I can do or X, Y, and I get true. See, it's a Boolean. I'm ORing X and Y, and X and Y right now are Boolean values. So that OR works, and I get back a Boolean value. Okay. And this interpreter keeps showing you the environment. If you start up a Python interpreter, it's not going to show you its environment. Though a lot of Python interpreters do have a little command. There's a command you can type usually to say, show me what the environment is. So if you start up a Python interpreter or a JavaScript interpreter, I don't think about JavaScript, but in a Python interpreter, you can ask it to print out the environment. Okay, so language 3 is a language of Boolean expressions, arithmetic expressions, and variables stored in an environment. And variable values stored in an environment. You can use literal values in this language or variables, and the variables have their values stored in an environment. Okay. Now, before going into the details of what eventually want to look at how this language works. But before that, let me just show you what language 3A is. Your homework assignment is language 3A. Okay. And then we'll start looking at how language 3 works. Okay. Where's clean? Okay. Your homework assignment is a language 3A. Here's the syntax for language 3A. It's language 3 with 5 new operators. Okay. It's language 3 with 5 operators. A post-increment and post-decrement operator, a pre-increment and a pre-decrement operator, and something called the spaceship operator. Okay, I'll show it. You probably never, I don't know, maybe you've never heard of the spaceship operator. It's kind of a new operator that's showing up in languages. It's not in Java, but it's in C++ now. It's not in Java, it's not in C. It is in C++ and a few other languages. It's kind of an interesting little operator. And it's referred to as the spaceship operator because it kind of looks like the spaceship from some video game. Okay, so the operators are a less than symbol, equal, greater than symbol together. It's a 3-character operator symbol. Okay, all right. Now, in C, that's post-increment, and that's pre-increment. But in our language, everything is written in a tree format. So here is, now I can't have that be there. I can't write this. That would be like a tree, but that's not going to work in our language. We can't have a pre-increment X and a post-increment X. That really isn't going to work. So here's how we do pre and post-increment. Okay. So here's post-increment in C, in Java. In our language, it'll be plus plus X is actually post-increment. This is pre-increment. In our language, pre-increment will be 3 pluses in front of the X. So 3 pluses means pre-increment. That means increment X before you use it. 2 pluses mean post-increment. That means use X first and then increment it. Just like this means use X first and then increment it. This means increment X first and then use it. So we'll use this prefix notation for the pre-increment operator. And we'll use this prefix notation for the post-increment operator, and the same thing for the minus minus ones. So for the minus ones, it'll be, here's the decrement operator. There's the decrement operator in C, C++, and Java. In our case, the decrement, the post decrement operator will be like that. So that means use the variable and then decrement it. This is the pre-decrement operator, which means decrement the operand, then use it. So decrement first, then use it. In our case, that will be minus 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 x. Okay. You have to add these operators to the language. You have to add these 4 operators to the language. Okay. In the homework assignment folder is a bunch of examples of using the language. So here's a gazillion expressions using these new operators. Okay. So for example, this is an error. You can't increment a literal. See, not in Java won't let you do that either. You can't increment a literal. This is an error too. You can't decrement a literal. Okay, you can check that in Java. If you go back over here to the Java visualizer, you'll see that it doesn't make sense. I mean, you might think it makes sense to write 3++, but it won't compile. You cannot decrement or increment a literal. Okay, the Java language, you might think that means 4, and it wouldn't be a bad guess. 3++, they maybe could have written the language to let you mean that that would be a representation for 4, and this would be a representation for 2, but they don't. You cannot increment or decrement a literal value. Okay, so our language, it's an error to increment or decrement a literal. Here, you're decrementing a variable that hasn't been declared yet, so that's an error. Okay. Here, declare variable 3, but this is not the right, this has got too many operands. See, this is decrement, this is increment x, but it doesn't make sense to say by how much. This is a unary operator. It only takes 1 operand. So the syntax was this syntax here. It only takes 1 operand. See, it takes 1 operand and it must be a variable, not a literal, not an expression. You can't, another thing you can't do in Java, for example, is this doesn't make sense. X plus Y. That does not mean add X and Y, then add 1 to the result. That just doesn't compile. Okay. Now I should put that. I have an X and a Y. Well, it just won't compile. Okay. There is no, you cannot increment an expression. You have to increment a variable. The only thing that's allowed is to increment a variable. That's the only thing that's allowed in Java. Okay. You can't increment literals and you can't increment variables or expressions. You can only increment variables, not expressions or literals, only variables. So the syntax is really restrictive. And same thing is true in Java. The plus plus and minus minus operators only act on variables. Okay. So this would be an error. Well, this one would be an error because it's taking too many operands. And this one's taking an error because it's acting on an expression. It's trying to decrement an expression. So you cannot decrement an expression. You cannot increment an undeclared variable. You cannot decrement a literal. And there's only supposed to be 1 operand in the increment. So this is checking for runtime errors. Then these are legitimate, then down here are legitimate examples. Okay. X is 3, print plus plus x. Now plus plus x means post increment x. So that'll print 3, then change x to 4. So this x will be 4, but it'll print 3. This would be pre-increment x. So this would be x is 3, then x is incremented to 4. It prints 4, and then x is 4. Okay. So, you go through these, these are all the variations on examples of using the pre and post increment operator. Okay. And then there's more elaborate examples of using the pre and post increment operators. Okay. Now, there's another operator you have to add to the language, the spaceship operator. The grammar of this language has this thing called the spaceship operator, which is a binary operator acting on two expressions. Okay. And in the folder, when you get the folder for the homework assignment, there's a Wikipedia page about the spaceship operator. It's a form of what's called three-way comparison. The spaceship operator does what compare does in the Java language. Okay. When you compare two numbers, you get back either -1, +1, or 0. Okay. And that's what the spaceship operator does. When you do the spaceship operator on two operands, you get back either 0 if the operands are equal. You get -1 if the second operand is greater than the first operand. And you get back 1 if the first operand is greater than the second operand. Okay. So it's asking, is the first operand greater than the second operand? If the first operand is greater than the second operand, you get 1. So in a way, it's telling you, are these things in the right order or not? Is this greater than this? +1 means yes. Is this greater than this? -1 means no. Is this greater than this? 0 means they're equal. Okay. So it's a three-way comparison. Instead of giving you Boolean values, it gives you plus, minus, -1. Let's see. There was a list of languages that have, oh, here it is. Perl, Ruby, Groovy, PHP, Eclipse, C++. Those are examples of languages that have adopted this spaceship operator. And there's another link here. Here's a list of all the operators in C++. And here's the increment and decrement operators. And then see, here's the spaceship operator. This Wikipedia page points out that it's in C++, but it's not yet in C. I don't know if it's been added to C yet. I don't think it has, but it's not an operator in the C language, but it is an operator in the C++ language. I'm not sure when it entered the C++ language. I think it was pretty recently. I think it was fairly recently that it was added to the C++ language. Okay, so you have to add a spaceship operator to this language. Okay, and down here is the semantics of the spaceship operator. Here's what the spaceship operator should do. If you give the spaceship operator an int and a Boolean, it'll throw an error. You can give it 2 Booleans or 2 ints, but not an int and a Boolean. So first, if you give it a mixture of int and Boolean, it'll throw an error. If you give it 2 ints and this x is less than y, it returns, let's see, I think it was, yeah, if x is less than y, it returns -1. If x is greater than y, it returns +1. If they're equal, it returns 0. So it's the same thing as that Wikipedia page was showing. Where is it? Yeah, it's this. Okay, so it's the same idea as this thing here. Okay, all right. But for Booleans, it's a little bit quirky. I'm treating false is to the left of true, if you think of it as like on a number line. Like in C, false is 0 and true is 1. So if x is false and y is true, that's -1. That's like this. Because I'm thinking of x is less than, I'm thinking false is less than true. Okay? If x is true and y is false, it's +1. And if they're equal, it's 0. And I think this is equivalent to exclusive OR, maybe. I can't remember for sure, but this is something like exclusive OR. I think. Kind of like, it's kind of like an exclusive OR operator. Okay, so that's what the spaceship operator should do with 2 Booleans. And here's what the spaceship operator should do with 2 integers. And if you give it a mixture of a Boolean and an integer, it should throw an error at runtime. Okay, you know, like we see over here. Let's see, do I have? Oh, if you do this with a Boolean and an integer, see, it'll give you a wrong type of argument. But if you give it two Booleans, or if you give it two integers, okay, so it'll do a comparison, like if I reverse the order of them, see, it switched from 1 to -1. And if they're the same, see, the spaceship operator returns true, 0. 0 for equal. So it's another it's both a comparison operator and an equality operator. That's why they call it a three-way comparison operator, because it tells you greater than, less than, and equal all at once. It does what compare does. Java has a compare method that returns either +1, -1, or 0. So the spaceship operator it acts kind of like the compare method in Java. Yeah. So if you went to Java and you Googled the Java compare, yeah, people point out that the compare operator returns either 0, -1, or 1. See, same idea. So the compare method acts like the spaceship operator is just kind of a simple way to write a compare method. Okay, so but in Java it's the compare method that's in the object type. So it's something you can overload yourself from the object class. So you're supposed to write this method for classes that you want to be able to compare objects to. If you've got objects and you want them to be able to compare to each other, you use this compare. You overload the compare method. Okay. All right. So you have to add those operators. Okay. So I say var x 0. So there's var x is 0. Then I say post increment x. Notice I get back 0 because post increment says look up x, which is 0, print out that value, then increment x. If I check now, see x has been incremented to 1, but the increment happened after x was looked up. Okay, so that was a post increment. And if I do var y 0, okay, if I do something like a pre-decrement of y, see that returned -1 and y is -1 because that got the value of y, decremented it to -1, and then it decremented it before it got the y. So it went to the environment, decremented y, and then got the value. The post increment one went to the environment, got the value that's going to print out, then after it got the value, then it incremented x in the environment. So the incrementing of x in the environment was done after getting the value of x. With this one, you get the value, you decrement it in the environment first and then get the value. So the value is going to show up here as -1. So that's a pre-increment, that's a pre-decrement, and this was a post-increment. Okay, so you have to add these operators to the language. Okay, all right. So that's the idea of the homework assignment. What we should do, we got a few minutes left, is start talking about how the interpreter really works. Let's go through, but we'll do that with language 3. So okay, I don't remember what I changed here. Oh. Okay. If we go back to language 3, we want to start walking through the whole process of how this interpreter works. Okay, so we're going to go through the details of how the interpreter is going to work. Okay, so what we'll do is Here's the program that uses the interpreter. So here's a bunch of strings in our language. Okay, and 1, 2, 3, 4, 5, 6. This is all one string. This is another string. This is another string. The prog statement lets you put a bunch of statements in one program. So you read this as a program is a sequence of expressions. Okay, so one of the things that language 3 added besides language 1 and 2 was the ability to sequence expressions. So program lets you sequence expressions. Okay, so this is one program, one string in language 3. Okay. All right. Now, what are we going to do here? We're going to iterate through each of the strings. Here's the key thing. Take a string, parse it to an abstract syntax tree. Build the abstract syntax tree first. Okay, so take that string, any one of them, like this string is a tree with print at its root and X as its branch. This is a tree with plus at the root, left branch X, right branch 2. This is a tree with 2 branches. That tree is its left branch of prog, and that tree is the right branch of prog. So prog lets you sequence 2 expressions, one after the other. So this expression is done first. This expression is a tree with that root and that branch, and this is a tree with that left branch and that right branch. Okay. Notice that this one's kind of funny. It's actually an invalid expression because it prints X before it declares it. So this will cause the interpreter to crash. Okay, it's a tree, it's a legitimate tree, but the interpreter, when it runs, won't like the tree. So the parser will build the tree for it, but the interpreter will say there's something wrong with this tree. So all of these have something wrong, not with the tree, but with the language. The interpreter finds something wrong. Okay, the parser will build a proper tree, but the interpreter will say, I don't like the tree. Okay, well, as we go through, we'll see how the interpreter does that. On the other hand, this is a tree with that root. That's the left branch. Then this is a tree whose that's the right branch of this. That says that tree has that as its root, that's its left branch, that's its right branch. Okay, it's kind of a funny statement. It declares X 2 times. It actually, it's really kind of goofy, but it puts X in the environment. What it does is it declares X and then updates it. So what it's really doing is it's declaring X, that's this one, and then it's updating X, that's this one. But it's updating it to the same thing it was. Okay, so it's just updating X to 2. So it's declaring X to be 2, then updating it to stay 2. Okay, so it's just a quirky little thing, but it should work. That's what the interpreter is supposed to do. This one will create X in the environment, then this one will cause X to be updated in the environment. All right, so the interpreter takes a string and builds the parse tree. Now, if there's something wrong with the string, the parse tree you could get a parsing error. I could have put some examples in here, like, for example, that's now a parsing error. That won't parse. It's not a tree. That's a parsing error. It's not a proper tree. That's a parsing error. That's not a proper tree. That's a parsing error. That's not a proper tree. Okay, so you could fail on the parsing, and if you fail on the parsing, down here you'll catch a parse exception. You could even fail on the parser. The first thing it needs to do is tokenize, and you can even have a tokenizing error. This thing might not tokenize properly, so there is no @ token in this language. So the tokenizer will say, I don't know what at's not supposed to be there in the language. So you'll get a tokenizing error on that one. But if you're building the string and the tokenizer throws an exception, you catch the tokenizer exception here. If the parser catches an exception, if the parser throws an exception, you catch the parser exception here. Okay, so this guy can throw either a tokenizing exception or a parsing exception. And if it doesn't throw either, then you have a legitimate tree. The tree might still not be one that the evaluator likes. The tree may not be something that the evaluator will accept, but it is a legitimate tree. Okay. After you parse the tree, it gets printed out, and it gets printed again, and it gets printed again. We'll talk about that later. So these are just printing the tree out just for information use. Okay. After printing the tree, the real key is to evaluate the abstract syntax tree. The evaluator gives us back what it thinks is the proper value of that expression. If the evaluator doesn't like the tree, then that's where it'll throw an evaluate error. So that'll throw an eval exception. So the evaluator, if it doesn't like the abstract syntax tree, it throws eval exception. Okay. And over here, if we run, let's see. Here's a tokenizing error. There is no @ token in the language. Here's a parsing error. That thing didn't parse right. Here's another parsing error. See? Now, here's a interpreter error. See, I got a tokenized exception, a parse exception, and eval exception. I'm trying to evaluate an expression with undeclared variables in it. There's nothing wrong with tokenizing that. There's nothing wrong with parsing that, but the evaluator says, well, I don't know what X is. So it's an evaluation exception, a runtime exception. Okay. In a real programming language, these are compile time problems. Tokenizing and parsing exceptions are compile time problems. This is a runtime problem, except that in C++, this would actually be a compile time problem. In C++, this thing wouldn't compile. But in our case, it's a runtime problem. Okay, so after building the abstract syntax tree, you try to evaluate the tree. Okay, and if the tree doesn't evaluate, you get an eval exception. Okay, so now drilling down into the code, there's two things to really think about. How does the tree get parsed? How does the tree get evaluated? Okay, now we've talked about the parsing before. The parsing is just this idea of building a tree. It's the easy part. The parsing is actually pretty easy. The only thing that we said before, the only thing that makes the parser kind of messy is it's doing a lot of error checking. It's looking for lots of places where there's mistakes. So almost all this code is looking for mistakes. See, now the parser is only one page of code, and majority of the code is stuff that's looking for mistakes. Okay, you can see how many lines of code. Majority of the lines of code are looking for mistakes. Okay, so it builds the parse tree and checks for things. So we've talked about that. The real thing that we need to talk about, we run out of time, and this is where we'll start on Wednesday. How do you evaluate the tree? Okay, how do you walk the tree and evaluate it? Okay, we never really did the details of even the arithmetic expressions and the Boolean expressions. Well, we did some, we did a little bit, we went back and forth. We've looked at a little bit of evaluating Boolean expressions and evaluating the arithmetic expressions and the Boolean expressions, but things are much trickier now because of the variables. Okay, so we're going to walk through this evaluator real carefully. Okay, and what you're going to do in your homework, see this eval expression, eval var, eval print, eval Boolean expression, eval equality expression, eval relational expression. You're going to write evaluate spaceship expression, and you're going to write evaluate, I forget what the other ones you call pre-post expressions. Okay, so you're going to write one of these methods to handle the pre and post decrement the decrement and increment operators, You're going to write one of these methods to handle the spaceship operator. So you're going to add two methods to this interpreter. One to handle the spaceship operator and one to handle all the increment and decrement operators. Just like this one handles all the EQ operators, there's two of them, equal to and not equal to. You'll write an expression that evaluates pre and post increment operators, and there's four of them. Pre-increment, pre-increment, pre-decrement, post-increment, and post-decrement. Okay, so you'll write a method to handle those four operators and a method to handle the spaceship operator. So you're going to write two methods. Okay, and you're going to have to understand, how to use this library to, and one last thing. When you write that code, you can almost do the entire assignment by cutting and pasting pieces from other methods into what you're going to write. You can almost do the whole assignment by cutting and pasting out of other parts of the interpreter, because there's a lot of redundancy in this stuff. So you'll read the interpreter to understand how it works, and then when you go to write the code, you'll see that it's a lot of it you'll either write it yourself or you'll actually look for pieces you can copy and paste to use. And a lot of what you'll need is buried in here somewhere, where you can just check. You can, like, here's what happens if you check for tree branch. See, if the degree is not the right number, you throw an exception. Okay. The recursive evaluating of the left and the right branch of a tree, you'll see all the code is in there. So we'll step through the code for evaluate in real detail, especially see how it handles environments. And then your interpreter, you'll just have to write two methods that add those five operators to the evaluator. Okay. All right. So we run out of time. Any last question? The exam will be up. The homework assignment will be up there later this afternoon. Any last question? Any questions? Okay. So after you see the assignment, if you have questions, send me email, because it's not a hard assignment, but it's an assignment meant to make you read the evaluator. The purpose of the assignment is to get you to read language 3 carefully, so you can more or less mimic what's going on in here and add a little bit to it. Read all this carefully. You only have to change. You'll have to change. We'll talk about this. You'll have to change this file and this file. This file evaluates and this file pretty prints. This is one of the pretty printers. So you'll have to add the 5 new operators to that pretty printer. So you'll only change those 2 files. You'll change the way the evaluator works, and you'll change the way this one pretty printer works. You'll add 5 new operators to those 2 files. So we'll talk about the evaluator on Wednesday. Any last question? Okay, I'll go ahead and stop sharing, and we'll meet again on Wednesday, and we'll start stepping through the evaluate code really, really carefully. That's probably we'll probably spend the whole time on Wednesday just stepping through that evaluate code. Okay, so but try to read it ahead of time. See how much you can make sense out of it beforehand, because it's pretty well commented. So I think it's pretty readable. I made the code real verbose for a reason, to try to make it as understandable as possible. Okay, so I'll stop there, and we'll meet again on Thursday. Okay, bye.